The role of the geotechnical engineer is mainly to explore the ground conditions to give the proper foundation.
Why North India is considered as highly seismic zone?
Because of the seismically active region is one parameter. Another one is its
Now the tectonic plates are moving faster, or we are just assuming it?
the Himalayas are also formed mainly due to movement of. So if I'm having the two different plates, this is one plate, this is another plate, either these two plates are coming towards each other or these two plates are moving away from each other. Sometimes we can't say on this day, at this time, this magnitude is going to occur. That no one can predict. If anyone is giving such information, it is false only.
The parrots, animals will sense the earthquake.
See, whenever water is there and sand soil is there, when the earthquake occurs, it will flow like a fluid. Earthquakes doesn't kill the people. Buildings kill the people.
Hello civil bros, welcome back to our channel. So watch till the end, let's begin the show. To discuss about latest earthquake and seismic zones in India. So let's start our podcast. Hello sir, good to have you here again.
Thank you, Andy. Thank you for inviting me again for podcast on seismic zonation map of India.
If we start with latest update of earthquake zones, what is the latest update is telling?
Actually, this is the timely podcast. Because recently, few days back only, Government of India has released this one BIS. So it has been released the latest seismic zonation map of entire country. In general, we will follow the IS 1893 code. So now they have revised IS 1893 2025 version. So in this, they have given the latest updation on the seismic zones. Previously in India, we are having the 4 zones basically, zone 2 to zone 5. 2, 3, 4, 5. So in the 2002 map, they have removed the zone 1 because zone 1 and zone 2 are more or less having the similar behavior. So they removed the zone 1 and they kept only 4 zones, zone 2 to zone 5.
Okay.
Now in the latest updation, they have included the zone 6. Zone 6 means very high risk. So now after modifying everything, if you see the latest seismic zonation map, then almost 61% of entire nation is under the moderate to very severe earthquake zones, high risk zones. So moderate to high risk zones percentage in India is now 61%. So now they have included so many areas under these categories. Previously very few areas of the Himalayan regions are under the high risk zone. Now they have kept entire Himalayan region including the Jammu and Kashmir and northeast states also under the high risk zone. So this is the latest update. So previously we used to have the previous history. Based on the history we are having the map, but now we have changed. Based on the geology of the area, we are giving this latest map. So which is going to be more realistical map also.
Okay.
One can say that one.
Previously when it was done, sir?
In 2002 version is there. So where they changed 5 zones to 4 zones.
Okay,
now
okay.
again they come back to 5 zones, by adding additional zone.
Okay, okay.
So zone 6.
Okay.
So in general, previously, if you see, if I'm having the 2 different areas, so I'm going to have the different zones. But now they consider the geology of the location. If 2 different states are coming under the same geology conditions, then we are going to give the high risk factor for both the states or both the regions.
Okay.
So which gives a significant improvement in the latest map also.
Okay, how they divide like these zones and all? How they decide?
In general, the zones will be divided based on various factors. Basically, based on the some scales. We are having the Richter scale, we are having the MSK scale. So Richter scale is based on the amount of energy released at the source, because earthquakes may occur deeper portions. So somewhere around 70 to 350 kilometers or sometimes 700 kilometers also. At what depth they occurred, what is the energy released? Basically, during the earthquakes, what is happening? We are having some tectonic plates. So these tectonic plates are going to be resting on the lava, molten lava. So because of this one, the plates are continuously moving. So if I'm having the 2 different plates, this is one plate, this is another plate, either these 2 plates are coming towards each other or these 2 plates are moving away from each other.
Right.
And sometimes they are going to be sliding one over the other, slipping also can be occurred.
Right.
So when it is moving, one is moving forward, the other may moving in the backward. So here, because of this slipping also, there is going to be some energy released.
Okay.
This energy has to be dissipated properly.
Okay.
This energy is very huge. So if I want to dissipate this one, how it can be? It has to travel certain distance, so that through the voids and gaps, slowly the energy is going to be absorbed.
Okay.
So because of this one, whatever the energy released below the ground surface, it is reaching the ground surface. So here, if I measure the energy at the point of release, which we can call focus, at the hypocenter or focus will be there below the ground surface, hypocenter or focus.
Okay.
So the energy released at that particular point, we are having the Richter scale. In general, Richter scale magnitude of 7 plus means very high magnitude.
Okay.
Sometimes even though 7 magnitude is there at the point of release, when it reaches to the ground, the intensity may not be the same because it has to travel and some energy will be dissipated. So because of this one, we are having another scale, MSK. This MSK scale will give the
Okay.
severity at the destination. Source is Richter, at the destination we are having the MSK scale.
Right.
So in general, MSK scale is having the number of zones again, 12 categories. Up to 6 categories, it is very less, no risk at all. So once it is crossing the 6th category of MSK scale, then we are having the problem to the society and the infrastructure also.
Okay.
So based on these factors, we are having the classification.
Why North India is considered as highly seismic zones? I saw the map also. Those zone is like very severe in condition for earthquake zones. So why? What is the reason for that?
If you observe, there the plate movement is very high, especially at the Himalayan region. So once the plate starts moving, then it is going to cause some issues to the surrounding areas also. And that too, in that surrounding, whatever you mentioned, Jammu, Kashmir or Northeast state, most of the times we are having the hill and valleys. So hill portion will be there, valleys will be there. Too many hills are going to present in that region.
Okay.
So because of this one, landslide is also one of the major issue. Every time we are seeing, whenever the people are traveling along those regions, because of the landslide, entire road has been blocked for days also.
Exactly.
So here, because of the seismically active region is one parameter, another one is its geological condition, how it is going to be there in the field. So either the hill, valleys and ridges will be there. So because of all these things, it is going to be some high risk zone. Even to construct any structure also, if we want to have the safer structure, we need to consider that high risk factor also.
So I wonder, like now the tectonic plates are moving faster, or we are just assuming it?
No, plate movement is more or less similar only. It is going to be constant displacement.
Okay.
So now if you see the tectonic plates below the Himalayan region, it is around 4 to 5 centimeter per year. It's very slow, but still considerable. So in general, the Himalayas are also formed mainly due to movement of the tectonic plates only.
Okay.
So when the plates collide each other, then they are going to raise the ground surface. From that, hill portions will be formed. So like that, when it is moving away from each other, then you are going to have the subsidence. So both will be possible. It is there, but we need to address these issues clearly. Then only we can have the safer environment.
Okay. Are we detecting more tremors in that area?
In general, it will be, because whenever some area is there above the tectonic plate movement, then obviously it will feel some tremors. It will be there, but how much intensity? See, some of the tremors may not be effective, because it's very small and we may not feel that vibration also, shaking of the ground, but it will be there. So to observe this one, India has installed more than 160 modern stations to observe this seismic activity of that region. So even some substations are also there to accommodate these things. So because of these things, we are having the more tremors, but out of this, few are going to have higher impact. So in general, when you compare the entire world, Himalayan region is one of the highly seismic risk zone. So we can expect magnitude of 8 plus also, which is going to be very catastrophic also if it happens. So we are having the tremors. It is going to be there. The way we analyze and we detect it is more important.
So as per recent report, which states or cities having the more risk of this seismic zone area?
Very important question, because it's very important to understand under what zone our location is falling under.
Exactly.
So if you observe this one latest zone, so entire that belt, Himalayan region from Jammu Kashmir to Northeast state, in everything in that region is totally under highly risk zone.
Yeah.
That means zone 6.
Yeah.
And in addition to this one, there are some areas where we are having the lower zone in the previous map.
Oh.
So that also to be considered as the high risk only in the latest map,
Right.
because it is almost close to the high risk zone. When high risk zone area is very close to us, then we may not ensure whether we are safe or not. We are not sure about the mechanism of the earthquake. So
Okay.
we need to consider the zones close to that area also highly risk.
So I want to know that how prepared India is for as per latest earthquake designs. So the infrastructure and all the things, how we are dealing with.
In general, we are having two basic codes for the earthquake resisting design of structures. One is IS 1893, it is for seismic design. Another one is IS 13920, it is for ductile detailing. So these two plays an important role. So if you want to design any structure that has to be safe against the earthquake, means we need to follow these two codes. But even though we are having these things and we are having some additional agencies like BAS, NDMA, these are going to take care of these things. The problem here is implementation level. We can't go and check every structure. So here the major thing is implementation at the root level. So we need to have some skilled labor, skilled workers and advanced equipment to construct all these things against the seismic forces. So there we are having the lacking. So we need to upgrade ourselves so that we can go for the modern structures which can resist the seismic forces.
What are they? Modern structure means?
Modern structures in the sense, first we need to understand the codes properly. If we can design the structure as per the code and if we construct as per the detailing part, because most of the times whatever the cross section reinforcement detailing is there, how many companies are following the same detailing, only few at the higher level. So if I see at the lower level, at the ground level, if I want to construct any structure, some G+3 or G+2, am I following the same detailing?
I don't know.
Not sure about that one.
Not sure, yeah.
See, in general, if we can ensure everything, each and everything that has been given in the IS code with some slight relaxation, then all buildings are going to be safe. See, in general, earthquake doesn't kill the people. Buildings kill the people.
Exactly.
If we didn't construct properly, then the buildings are going to kill the people. As per the statistics, in the last 25 years, more than 25,000 people lost their lives because of the earthquakes, especially during the, especially because of the improper construction and not following the guidelines only. So if we can ensure the following of the guidelines, strict compliances are there, then obviously we can have the safer environment.
Like what level of the earthquake they can take, like in terms of our infrastructure, what level of the number they can take?
See, it's not like that. If you see the Atal Tunnel and recent construction of Chenab Railway Bridge, these structures can take higher magnitudes only. So that we need to design. See, whatever the structure you want to plan, you must understand what is the maximum possible intensity of the earthquake in that region.
Okay.
So for that we need to study back. For the past 100 years, 1000 years, what is the different ranges of the earthquakes occurred in that region? What is the possible earthquake? We need to expect that one also. If the maximal magnitude of Richter scale is 8, then I need to design my structure to 8 or 8.5. So that even if 8 occurs, my structure is going to be safe in general. So those guidelines and those things has to be implemented strictly. Whatever the structure you take, if we are constructing the structure, means it has to designed as per the seismic codal provisions.
Right.
And even recently we are having the rail network to the northeast states also. You have seen those things. Yeah. So there also one of the problem is seismic activity. So there also we need to design that railway network to resist these seismic forces.
Okay.
So then all structures will be safe. If we design properly, then most of the structures can be safe.
Like what is the probability of getting 8?
It depends. You see, if I am close to the Himalayan regions, I may expect the 8 in another 5 years. another 10 years, another 100 years also. Whereas if I am staying away from like Andhra, Telangana, Karnataka, these regions may not have that much severe intensity earthquakes. They are having the moderate chances, but severity is very less. Here the prediction of earthquake is not proper. That means we can't ensure. Here you can say this much of magnitude may occur. It may occur in future, maybe down the line in 10 years or 100 years. But we can't say on this day, at this time, this magnitude is going to occur. That no one can predict. If anyone is giving such information, it is false only. Don't believe those things. It's not possible.
But then how we will detect earthquakes before only?
It's not like before. Rarely we can't detect. We can have an idea. This much of possibility is there. It's mainly based on movement. See, if plates are moving away from each other, so they are moving maybe some 2 to 3 centimeters per year. So after 20 years, it may move some 40 to 50 centimeters. If plates are moving from this point to some 40 to 50 centimeters, then how
the value will happen?
Geology is going to affect how the substructure of the earth surface is going to affect. So based on that one, if this is moving like this much of energy may be released at this point. So because of this energy, we may have this. It's all about the prediction only. It's not
that also predicted.
It's not exactly because we know only movement of plates. Because of that movement, how the things are going to be there, that also we know. So but exactly because for example, if I am having the two plates, so they are moving like this. One is moving and another one is going back. So if earthquake should be occur means once these two start moving, there may be a chance. And when I'm moving like this, there might be another chance. So we don't know at what point the energy is going to be released. That is not unknown to anyone.
So, but the parrots, animals will sense the earthquake quickly, better than us.
Here it's all depending on the hearing sense. Up to what frequency we can hear. Human beings can't hear all the sounds, but whereas animals can sense that frequencies from longer distances also. Even in the recent Wayanad landslides, the elephants have observed that one and they formed a closed shape. So they will have a circle type so that they will protect each other. So they will sense those vibrations. They have that capability, but not the human being. We are having only up to certain limit. So beyond that one, we can't hear. Construction companies really following the codes as per like which we presented in seismic zones also? Really? Obviously. They have to follow first one. And most of the time, the flagship projects or the structures of high importance, compulsory they will implement those details. Like I mentioned Atal Tunnel or the Chenab Railway Bridge or any of the major structure. So if I am going for the construction of the bridges along the rivers, across the rivers, then I need to follow these things. At the highest level, everyone has to follow. They are following. But when I come to the middle and lower level, see, at the lower or middle level, are the employees of that consent group are checking these things? Municipal level or any level, are they cross-checking the building construction aspects, whether they are providing the as per IS codal provisions or not? And if I want to construct my own home in the Himalayan region, for example, it is of G+1, highly seismic zone. So am I going to accommodate each and every detailing that comes from the design? Here the cost is also I need to take care. And since and here another reason is the earthquake may occur once in 100 years or once in 1000 years. I don't know. We can't predict. Sometimes it may happen immediately after construction also. So that's not in our hand. So as a common person, what I will think, instead of going for huge amount, so if I serve my purpose for today, it's better for me. Let's think of the future later. So because of these things, most of the low-rise structures may not having these specifications, and we are not following at that level. Only for the highest important structures only we are following the seismic guidelines. That everyone knows in general.
But I feel, sir, more beautiful nature is presented in that area only. That region.
Obviously.
I felt like that. When I sing the real beauty of North India like Kashmir, Himachal Pradesh, these
Assam,
valleys,
Manipur.
Assam. Yeah. These are really beautiful areas, sir. Regions also. Sir, and I want to know what common mistakes are happening in building construction in seismic zones mostly.
There are various cases. So one option is soft stories. If I am having the cellar, so in cellar we are having the small shops. We are going to have the shops most of the times.
Okay.
If it is commercial zone, then we are giving that space for the shops, and we are open. Cellar also there are shops.
Okay.
So if you see few of the things, and above that one, we are having the some large dimensions. The beam column dimensions are very huge. Whereas the below bottom structure is having the normal structure.
Okay.
So because of the heavy weight at the top, soft story is going to collapse. So this is one of the region. Another one is because of this one, like detailing part. If you observe the reinforcement detailing, then how we are giving the tie-up bars. Main reinforcement will be there, lateral reinforcement, tie-up bars will be there. So once it moves one circle, then we need to close at one end. So most of the times we are closing like this, 90 degrees bend. But this should be bent towards inside, either 45 or 135 degrees.
Okay.
Because whenever the earthquake occurs, earthquake is nothing but horizontal force.
Yeah.
If I am having only this one, so only like this is one side, this is the another side, or this is clear for you, 90 degrees.
Yeah.
When the earthquake occurs, these two simply separate.
Right.
But when I provide the 45 degrees inside,
Okay.
this is going to be inside. So when earthquake occurs, these are going to protect without having the separation of this lateral reinforcement.
Okay,
So
okay.
this is also we need to take care. This is at our level, at the ground level. And another one is highly irregular structure.
Okay.
If you see some of the things, you are going to have the L shape
Yeah.
or some random shape structures. Whenever the earthquake is occurring, if random or irregular structure is there, where the weak joint is
Weak
there,
point
at
is
that
there,
point
yeah.
it apply the force, then it is
Okay.
going to collapse.
Yeah.
Instead of that one, if I am having the regular structure, all sides same, then entire body act as a single
Will affect,
one.
yeah.
It can offer the resistance to that force.
Okay.
Another one is like water tanks, higher altitude water tanks. Even if you see some of the G plus 30 or G plus 40, instead of sums, if I go for the water tank, what is happening in case of the water tank? We are having the huge amount of the weight on the structure. So whenever the horizontal force, if this is the horizontal force, it hits at the bottom. Once it hits the bottom, the vibrations will be there. The building is going to have the vibration like this. At the top, very huge amount of weight in the form of water. Water only. Water can't resist the forces.
Exactly.
It can flow with the force. So because of this water tanks, most of the dam structures are collapsing.
Okay.
So if you observe the
it is extra burden, I guess.
Yeah.
Okay.
If you observe the previous collapsed structures, there are certain instances where one can observe entire apartment has been collapsed except the lift portion. Only lift portion stands that earthquake against that earthquake.
Okay.
Entire building has been collapsed. The reason is for the lift on 4 sides we are having the strong columns connected properly. So on 4 directions it is having the strength. It can resist. So whereas other structure we are not providing that much. And another reason is at the basement cellar parking. If you see the parking, are we having any walls?
I don't know.
Only for parking purpose columns will be there.
Columns will be there, outer will be there.
So if this is the first floor and this is the cellar, I'm having only columns everywhere. There is no connection between the columns also. The earthquake will occur attack the column base. Column is weak now. It is not supported by other column.
Exactly.
Then what will happen? Because of this weakness, it is going to collapse.
Why beams will be there, right?
Beams will be there on the top and bottom in general. Even though it is connected, the wall to column connection is not there. See, I think you heard about the shear walls. Nowadays, most of the multi-story buildings, they are providing the shear wall as per the guidelines. Shear wall means it is providing some connection between the walls and holding together. Lift type structure. Why the lift is not failing? It is having the strong connection and holding of that one. Similarly, the shear walls also connects the columns and it will take care of the lateral forces. Whereas in normal structure, we are not having that facility.
Right.
That's why most of the structures are failing.
Okay. So I guess the geotechnical part is very crucial here. So how you guys are ensure that safety?
See, the role of the geotechnical engineer is mainly to explore the ground conditions to give the proper foundation.
Okay.
If foundation is proper and it can take care of the external loads, then we can have the stable structure, first thing. Another one is we are having some techniques. Even the foundation is having failure, superstructure going to be safe. Like that also we can have.
Yeah.
Those techniques we may call as base isolation especially, or providing the dampers in the superstructure. Just energy absorption only.
Right.
So the main role of the geotechnical engineer is to understand soil behavior. During the earthquake, how the soil is going to behave. Based on this one, we need to give the appropriate design. Based on our design, if the foundation is constructed, then it is going to be safe only.
I heard about liquefaction also recently. So how it will affect the structure or subsection?
One of the important aspect to understand related to the soil here. So here liquefaction is nothing but the word itself, liquefaction. So the entire soil moves like a flow of liquid. So it will move along the water. So now if
Along
you
the flow.
yeah.
Along the pressure.
Now if you observe along the coastal regions, so for example if I take the Vizag area, coastal region is there, near to the coastal portion we are having the houses, beach road is there, beside that one you are having the structures also. Now whenever earthquake occurs, all these structures are under risk. Why? In general, it is very close to the water body. What is the soil available in that coastal regions? Sand. If sand is there, water can easily pass to the sand.
Yeah, percolate in that.
Obviously, the water is going to be there below our foundation.
Exactly.
It will be there. And we are going for the construction. Now, what is happening? If this is the ground surface, this is the ground surface. Below this one, here it is the water. So now what will happen? Is there any chance water to flow in the upward direction because of the heavy weight?
Okay. There is
weight is there, so it can't move in the upward direction. The only direction is it can move in the horizontal direction. Earthquakes means lateral force. Once the earthquake strikes here with huge energy, very huge energy, what is happening when the huge energy is applied here? It has to absorb or it has to move.
Yeah.
So water in general it will move.
Yeah, exactly. Yeah.
In general. So if I struck here, water starts moving.
Right.
Here the applied energy is very high. If the energy is high, water will flow with high velocity or low velocity. High velocity.
Yeah.
The soil below our structure is sand. When water is moving with high velocity, is the sand particle stay at the same location?
No.
It will move along with the water.
Right.
Because of the earthquake, the entire water carrying the soil particles. Now, if you see, previously foundation is there, superstructure is there, my soil is there. Now, is there any soil?
No
soil. Then what about my structure?
It will collapse.
Yeah. This is the major reason for the damaging of number of structures along the coastal region. Liquefaction is one of the most important parameter which causes the huge damage to the structures along the coastal regions.
Anywhere happens, sir? Give me an example, sir. That's it. I'm just asking.
So, if you observe the previous earthquakes of Indian history, then we are having this liquefaction occurrence during the 2001 Bhuj earthquake and recent Kashmir earthquake also, we can observe these phenomena. So, it is there. Initially in the world, it has been observed in the Nagata earthquake in Japan during the 1964 and Alaska earthquake in the same year. There, they identified liquefaction behavior initially.
Okay. Both happened in liquefaction only.
See,
like where?
If earthquake occurs, then it will cause the liquefaction. Then structures will damage.
Okay.
Liquefaction will occur under this type of the conditions only. So earthquake induced liquefaction we are calling clearly. Earthquake induced liquefaction. Because there are certain factors for liquefaction, but earthquakes will cause the liquefaction predominantly.
There are some types of earthquakes also, or one earthquake or
any earthquake, if water body is there, see, whenever water is there and sand soil is there, when the earthquake occurs, it will flow like a fluid.
But Kashmir is not soil.
Here, whatever you are saying, it may not be exactly sand, but silt, fine-grained, cohesionless soil is there. It's not exactly sand. Why I have taken this Vizag is, it is going to clear example.
Right, yeah, exactly. I got big doubt in my mind. With today's technology, with today's implementations, practices, can we predict earthquakes in today's world?
We can predict the earthquake in the sense it's not exactly on what date. In future, this much of magnitude of earthquake may occur. That indication we can give.
So, how useful that early warning systems are, sir? If in case we can predict the earthquake means, how useful that will be?
See, here the alert system will work once the earthquake occur only. Before that, it can't give any alert.
Okay, so now it's happening means it will give an error. Okay, it will give a sign.
In general, the earthquake may occur below the ground surface. Sometimes it may be 70 kilometers or sometimes it may be 700 kilometers. We are having 3 different zones: lower, moderate, and deeper. If shallow focus center means 0 to 70. Medium means 70 to 350 or 300. 300 to 700 kilometers is deeper portion.
Okay.
So here, once the energy is released, it will have the different waves. How the energy will reach the top surface is based on the wave propagation. Here we are having 2 types: primary waves, secondary waves, and P waves and S waves. So here, S waves takes some time. S waves means surface waves. So
Right.
it has to reach to the surface. So to reach to the surface, it takes some time. In general, from point of source where the earthquake occurred, from the to ground surface, to reach this energy, we may have hardly 30 seconds.
30 seconds only? Oh.
30 seconds in general.
Okay.
Sometimes it may be less also. 5 seconds or 10 seconds.
Okay.
We can alert the people within this short duration.
Oh.
Because once the energy is released below the ground surface, that energy releasing can be captured by the sensors. Once the sensor captures this much of energy released means it is a earthquake.
Okay.
Then it will give the immediate signals to surrounding people and surrounding areas. It will give the alert messages. Even if you see during the recent cyclones also, we are having the mobile alert messages. You can observe that.
Yeah.
So like that, it is going to give the alert message. In general, in collaboration with the Uttarakhand state, IIT Roorkee has developed a system of alertness warning system.
Okay.
So it is effectively using these things. But the only problem is we have the timeline of 30 seconds.
Okay.
Within that 30 seconds only, we have to do anything.
We need to move.
Yeah.
So you told that we got 30 seconds only to escape. So how they need to protect themselves? What are the ways are there? What they need to do immediately?
Okay. This is like awareness to all the citizens. So if you see, there are various situations. During the earthquake, I may be inside or outside.
Yeah.
So I may be indoor or outdoor.
Exactly.
So if I am indoor, what I have to do? If I am outdoor, what I have to do? If we are in our house, if the earthquake occurs, then what is the first instinct? We are going to run. So we thought of running and we are going for the stairs and we are going for the lift. We should not do all these things. The only thing we need to do is bend, cover, hold. Bend means we should not stand. We should be on our knees. So we have to bend on our knees and we need to have a cover. You need to take a protection of any table or dining table will be there. So just go below the dining table. So you are having the cover and hold in that position only. Don't go towards the windows or any objects which are having the falling nature because of these forces.
Okay.
Then it is going to cause the damage to us also. This is when we are in the indoor. If you are outdoor, you are driving a car, suddenly you received the alert message or you heard the vibrations, shocks, then just stop the car slowly, get down from the car and move to the vacant land. Don't stop your vehicle below the bridges, flyovers, any wires like electricity poles. So we should not, any trees, we should not be there surrounding these things, either the bridges, flyovers or electric poles or any trees. We need to go to a vacant land so that you can protect yourself. There also again you need to bend. It's not like standing. So this is indoor and outdoor. Once the shocks completed, stopping, so the earthquake shocks have been stopped, then what we have to do? What we thought immediately, okay, the shock vibration is not there, so we are safe, we can move freely. No. In the earthquake, there are aftershock word is there. Aftershock means Once the earthquake occurs, after that also, after some time, the vibrations are going to be there, but they are not continuous. They are going to be in a time intervals. So once the earthquake stops now, you may expect immediate tremor or immediate vibration or immediate shaking also once this is closed. So at that time also you need to follow the same guideline. So unless you received the message from the local authority that the earthquake vibrations have been stopped, till that please be in a safe location and follow the guidelines and instructions given by the competent authority. In that way we can save ourselves.
Okay, but how we can save structures? What are the inputs, like what are the measures we need to take? What are the technologies there to resist the earthquake?
See, for structures, if I want to have the safer thing means I need to follow the guidelines, no other option, as per the codal provisions. So IS 1893, you need to go for designing of structure. If you are going for the ductile detailing, you need to go for that codal provision only.
American codes are there. Is there any other implementations, any advanced technologies they are following instead of us?
See, in general, if you see the Japan, because Japan is the one country where more number of earthquakes occur in a year.
Yeah.
It is on a ring of fire, active fault zone. So continuous earthquakes will be there. Here, if I want to safeguard my structure, then we need to build with certain guidelines. Those guidelines basically providing the dampers in the structure, providing the base isolation methods. So if I follow these things, we can avoid the damage to the structure. Even the Burj Khalifa is also having the dampers and other isolation techniques also.
Okay.
So for most important structures, always better to implement all these technologies which can safeguard your structure against the earthquakes. So other countries, they are following these things, and even in our countries also we are following few of the techniques like base isolation, these things for most important structures. So those are mandatory.
Sir, I have one small doubt because of this technology thing. Those guys are implementing such technologies. What do you think of it, like when we are going to adopt them?
See, we can adopt at any point of time. The only thing is we need to have the strict rules.
Okay.
Every structure should have these type of things, especially the structures of major importance, high risk structures. If I am having the hospital, school buildings, where school building means children's only will be there. So small kids. So there we need to have the strict guidelines. Hospital, where we are going to have the number of people, that there also we need to take it. So like these few important structures, if we implement the strict guidelines and the contractor also adhere to these compliances, then we can have the safer structures.
So is there anything like seismic ability influenced by environmental changes?
You make climate changes.
Changes, that's what I meant.
In general, tectonic plate movement doesn't have the environmental factors into that. It is resting on the molten lava and other parameters, mantle region. So because of the changes in the mantle only, these plates are going to move. But there are few instances where we may have the earthquake other than this plate movement. For example, if I'm having the landslide, tall hill will be there. So land is going to sliding along the slope. Mainly this is due to rainy season. That is also climate change. So because of this landslide, when the huge amount of land is sliding, so when it hits the ground, it will not hit smoothly. With huge amount of pressure and weight it is hitting. Once that huge amount of weight is hit the ground, then what will happen? It cause some vibrations, tremors. So this will cause the minor earthquakes. May not be that important, but we need to consider this effect also along the hilly regions. This is one. And if you see the Antarctica regions where completely it is ice, if plate is there, above the plate we are having the ice block. So after a certain time this ice block melted. Now the weight applied on the plate is less. Since the weight is less, the plate may try to move away. Because still then this glacier is going to hold that one, the weight of the glacier. But now that weight is not there. Then the plate starts moving. This is also one of the reason. So like this, the climate may have some slight impact, but in general, tectonic plates movement means no effect of climate change. Very minimal. Occasionally you may have, but not genuinely.
So do you know when we are going to have high-rise buildings, heavy blasting will be there. So that in that area we need to take permissions for that. But what type of measures they take? Is it affect our ground?
Obviously, see, whenever we are going for the blasting, what is the basic concept of blasting? We are placing some detonators or explosives below the ground surface so that we can loosen up the soil. So how to loosen up the soil? It's not only soil, even rock also you can break into particles. So if I want to loosen entire area, subsurface, then we need to have some explosives. Explosives, when they burst, when they explode, then it causes some vibration. Energy is going to be released. This energy causes vibrations. Because of that vibration, it is going to break down. So here, there is a particular pattern of blasting. And we need to take the prior approval. And there are certain guidelines. How much amount of explosives we need to use in the blasting process. That much amount of explosives of that category, because there are various explosives. Out of all, what is the suitable for that particular ground condition? And if it is within the limited quantity, then it will not have that much effect. But still, whatever the precaution you took, that vibration will move forward. It has to reach surrounding areas. It will reach because the vibration means whenever there is a solid area. For example, if I take the small room here,
the impact will transfer, right?
Obviously. Only, so it is going to keep on moving and you can feel that vibration also. But it's not going to be that problematic.
Yeah, so I wonder what lessons are we learned from recent earthquakes and all the things happened in recently. What type of lessons we have taken from them?
If you see the all past earthquakes, the only thing we can observe is earthquake doesn't kill the people, but the buildings do.
But structures do.
Yeah, buildings mean structures do. So here we need to understand few things. If you see the past few earthquakes, where the majority of the damages occurred is soft soils. If the soil is soft, then you are going to have the more damage to the structure.
Right.
And we are having some dumping yards. If you take any local municipality, entire waste is we are going to dump at one location. So like that, the dumping area is filled with this loose materials. So this filler portions also having the more damage. And if you see some of the areas where these dumping yards later after 10 or 20 years, they are converting into a construction area. They are building some structure. So once the earthquake occurs, the first area going to damage is that filled area because of the low strength, softness of the material. So this we need to take properly. And another one is enforcing the guidelines. We are not enforcing all the rules and regulations clearly. So this will cause the failure of the structures. We need to take care of this. Another observation, if you see that one, if we provide the awareness, if we provide the mock drills, so even nowadays in all the colleges and even schools also, they are conducting these mock drills against the earthquakes. Not only earthquakes, fire safety, everything. So once the earthquake occurs, how we can protect ourselves? As I mentioned previously, bend, cover, hold. These techniques we are teaching them in a mock drill. So this shows a significant improvement in the reduction of the death rate. So that is also we can observe. So these are the few observations we can take from the previous earthquakes.
Are we moving in the right direction towards precautions, like in terms of preparedness?
Obviously, we are moving. See, if I am changing my seismic zonation map, means I am considering so many factors. By including those factors, I am changing my map. So that I am preparing my area for the future possible risk also. And here, if you observe, we are having one app also, Bhudev. Bhudev. One app is there. So Uttarakhand state government along with the IIT Roorkee has given these guidelines. So that is going to give the alert messages to the people also. And if you see the previous constructions and today's construction, there is a drastic change in the design methodologies so that the structures can take care of the loads, seismic forces. And we are having the advanced retrofitting of structures also. Even the structure is damaged, we can have the retrofitting so that can be sustained. And the major problem here with the most of the areas is our structures are not new. Some of the structures may be constructed 30 to 50 years back, and some are there 100 years also. So those old structures we need to strengthen. before any earthquake occurs and hit that building, if we can strengthen the existing structure, if we can provide the retrofitting to that structure, then we can have the safer structure. So like this, we are moving in the right direction by including the smart advanced materials also. So now we are having the fiber reinforced plastic sheets for the retrofitting of the structures, which can lightweight and which can take care of the more absorb the shocks also. So these things make us ready for the possible earthquake, so we are prepared. But it is not up to the mark as we expected. Whatever the lessons we learned from that, we are taking some actions, and because of this one we are having the some advancements. But this is not enough to face any earthquake in future, especially the Himalayan regions of magnitude of earthquake may be around 8 plus. We may not be ready for that much of magnitude, but slowly we are moving in the right direction.
It's a great podcast, sir. And is there anything you want to tell our audience regarding our seismic zones, regarding our seismic zones, earthquake zones? Do you have any message you can say?
Always, if you want to have the safer structure and safer environment, and we need to protect ourselves from these type of the disasters, then we need to follow the codal provisions strictly, and we need to follow the guidelines given by the competent authority during the earthquakes also. And we have to conduct more number of the mock drills from the schooling stage onward, so that each and every person have some awareness on the earthquake, how to evacuate during the earthquake, how to protect us from the earthquake. And as far as possible, if you are buying any structure, any building, then ask the contractor or the builder to provide the design of that building, whether they comply with the seismic codal provisions or not, their design. So like this, if you keep on asking the people, then they are going to think of this direction also to implement the codal provisions. Always stick to the guidelines.
Wow.
So the only thing we can observe is earthquake don't kill the people. It is the buildings. Buildings do this thing, not the earthquake. So if you have the strong building, safer building, then we are also safe against any type of the earthquake.
Right. Wonderful, sir. This is a great podcast in our channel. So once again, thanks a lot for this podcast. And if you guys have any doubts about this episode, or if you guys have any future podcast planning also, you can comment below and let us know what are your takeaways also. And thank you so much for watching. Don't forget to like the video and subscribe to our channel. Your subscription, your subscribe or your support will boost us to do more podcasts, similar kind of passion, similar kind of attitude, and similar kind of information I will take care of. And yeah, that is it. Thank you so much. Thanks a lot, sir.
Hope this is going to create awareness among all the citizens of India. Hope it will reach to the maximum extent. Wish you all the best for your channel.
Thank you so much, sir. Thank you.
Thank you.
Please comment your takeaways from this video. I hope you enjoyed it. You learned something from this video, and please support our channel by subscribing, by following, by liking our videos. See you on next video.